Let's talk about intercepts. Just to orient ourselves exactly where we are in math world right now, we're talking about coordinate geometry, so that's x and y axis. And what this is all about is translating algebraic functions onto graphs, right? We use x and y points, and we can make a graph from that. So just as an example, let's take a nice, easy function here, y equals 2x plus 1. So what we could do is pick out a few points that would appear in this function, i.e. some points that satisfy this function. I don't know, what happens if we plug in 1 for x? Well, let's see. If we plug in 1 for x, then that becomes y equals 2 times 1 plus 1, so 3. And again, this is just some review here. And we can do the same thing for 2. And when we do that, I'll invite you to do it on your own. It spits out 5. When you plug in negative 1 for x, it spits out negative 1. And when you plug in 0, it spits out 1. And so we can take all those points and put it on a nice, pretty graph like this, and we can identify them on the graph. See, we got 1, 3 right there. There it is, 1, 3. And we got 2, 5 right there. We got the point negative 1, 1. Negative 1, 1. And the point 0, 1. Now, this particular lesson, I'll write that in, 0, 1. This particular lesson focuses on this type of point. That is an intercept. An intercept is where the graph meets one of the axes, be it x or y. And so that's our definition, right? An intercept is the point at which a graph crosses the x or y axis. So if I take my graph that I was just looking at and zoom in on it a little bit, I'm interested in the points where this graph crosses the y-axis and the x-axis, right there and right there. But let's get a little more mathematical about this. At the y-intercept, the value of x is 0. And we can see that, right? This is the point 0, 1. And conversely, at the x-intercept, the value of y is 0. What point is that? Well, it's the point negative 0.5, 0. Right? The y value here is 0. And that's it, right? They're going to make this a little more complicated, but let's take a look at what you could see on the test. Very often, you're going to be asked to find the intercepts from an equation. So why don't we use the one we were looking at before? Y equals 2x plus 1. And again, that's what the graph looks like, just for reference, but we're going to be doing this so that you don't even have to graph it. We know that the graph crosses the y-axis when x equals 0. That's what we talked about. So essentially what we're asking is, what is the value of y when x equals 0? Okay, well, why don't we just plug in 0 to this equation? Y equals 2 times 0 plus 1. So that's 0 times 2, 0 plus 1. It's 1. And so the y-intercept of this equation is 1. I didn't even need to graph it. You'll note, if you know your linear functions well, that the y-intercept is always the b in the y equals mx plus b equation. But that's for another lesson. Feel free to check out linear functions for that. All right, but how about the x's? So suppose we want to know what the x-intercept of this line is. Well, if the x-intercept is where y equals 0, then all we got to do is plug 0 in for y. So let's do that, right? In this case, it's going to be 0 equals 2x plus 1. So we have to do a little more algebra here. Let's subtract 1 from both sides. There we go. We got negative 1 equals 2x. Divide both sides by 2, right there, and I get x equals negative 1/2. And sure enough, that's what we see on the graph, right? So we don't even need the graph to calculate what the x-intercept is. So let's do some practice here just to make sure we have the hang of it. What is the x-intercept of the function y equals 7x plus 14? So you can go ahead and stop the video right now if you want to do this on your own. And now we'll do it together. Okay, we're looking for the x-intercept. That means the point where y is 0. So how do we find that? Well, we talked about this. We just plug 0 in for y. So I say 0 equals 7x plus 14. and then I'm going to subtract 14 from both sides. There we go. And that gives me negative 14 equals 7x. So now I'm going to divide both sides by 7. And that leaves me with x equals negative 2. So the x-intercept of this line is negative 2. Put differently, as a point, that's negative 2, 0. All right, let's do another one here. What is the x-intercept of the function y equals 3? So if you want to try this on your own, go ahead and pause the video here. And now let's do it together. Okay, so again, we want the x-intercept, just like before, right? So let's do what we did before and plug in 0 for y. Well, 0 equals 3. What does that mean? I mean, when will 0 equal 3? Well, the answer is never, right? At least not in this universe. There's no case where the number 0 equals the number 3. So what does that mean? Well, it means that there is no x-intercept. Kind of a tricky question, right? But if you want to see this on a graph, here's what it looks like. If we graph the function y equals 3, all we're saying is y equals 3 no matter what x is. When x is negative 4, y is 3. When x is negative 2, y is 3, and on and on and on and on. So this graph does not cross the x-axis, and therefore it does not have an x-intercept. We can see that graphically and algebraically. And finally, this one. Which equation could be represented by the graph below? So go ahead, put the video on pause again, and then we'll take a look at it together. All right, here it goes. So at first blush, this looks like a pretty difficult problem. We have some wild exponents here. We got a curvy graph. What are we supposed to do? Well, very often on the test, you can eliminate most or even all of the incorrect answers just by focusing on the intercepts. What do I mean by that? Well, let's take a look at this, right? This is the y-intercept of this graph. It's where the graph crosses the y-axis. And I don't know exactly what that number is, but I do know that it's negative, right? That's a negative number. So that means if I plug in 0 for x, I should be left with a negative number. Well, let's see what happens when we do that. Plug in 0 for x right there, goes away. 0 cubed is 0. Plug in 0 for x right there, that whole expression goes away. And what am I left with? Well, negative 7. So that could work. That could be the y-intercept. What happens if we do it for b? Plug in 0 there, goes away. Plug in 0 there, goes away. Plug in 0 there, goes away. Nope, that doesn't work. That's a positive number. I need a negative number for my y-intercept. All right, how about here? Plug in 0 right there and 0 right there. And negative 3 times negative 7 gives me positive 21. No thanks. I need a negative number. And then finally, if I plug in 0 right there, that goes away, and I'm left with 3. Doesn't work. So just by testing the y-intercept, I know that the correct answer to this problem is A. And so the takeaway is, when you see a complicated graph, one of your first checks should be about the y-intercept. Very often you can eliminate most or all of the incorrect answers using that. Correct answer to this one is A.